Have you ever wondered how computers seem to be getting smarter every day, how your phone can predict what you're going to type next, or how Netflix knows which shows you'll love? The answer is machine learning. Machine learning is a type of artificial intelligence that lets computers learn from data without being explicitly programmed. Imagine teaching a dog a new trick. You don't program the dog's brain. Instead, you show it what to do, reward it for good behavior, and over time, it learns. Machine learning works in a similar way. We feed computers massive amounts of data and let them find patterns and make predictions on their own. The more data they process, the better they become at making accurate predictions. Just like humans learn from experience, machines improve their performance over time as they're exposed to more data. It's like riding a bike. The more you practice it, the better you get. Let's start with supervised learning, one of the most common types of machine learning. Imagine you're teaching a child to identify different fruits. You show them an apple and say, "This is an apple." You repeat this process with bananas, oranges, and grapes. In supervised learning, we provide the computer with labeled data, meaning each piece of data is tagged with the correct answer. This is like showing the computer those labeled fruits. The algorithm then learns to map the input, the image of a fruit, to the output, the name of the fruit. One great example of supervised learning is email filtering. Have you ever wondered how your inbox keeps spam emails at bay? It's supervised learning. We train the algorithm on millions of emails, labeling them as spam or not spam. With enough data, the algorithm can learn to identify patterns and characteristics of spam emails, such as certain keywords or sender addresses, and automatically filter them out, keeping your inbox clean and organized. This process not only saves time, but also enhances productivity by ensuring that important emails are not lost in the clutter. Supervised learning is a powerful tool that helps in various applications, from simple tasks like fruit identification to complex ones like email filtering. It's fascinating to see how teaching a machine can mirror the way we teach children, making technology more intuitive and efficient. Now imagine you have a big basket of different fruits, but this time there are no labels. Your task is to group the fruits based on their similarities like size, shape, and color. This is similar to unsupervised learning. We give the computer unlabeled data, and it has to find patterns and relationships on its own. It's like giving the computer that basket of unlabeled fruit and asking it to sort them into groups. One common application of unsupervised learning is customer segmentation. Companies often use it to group customers with similar purchasing habits or demographics. This helps them tailor marketing campaigns and improve customer satisfaction. For example, an online clothing retailer might use unsupervised learning to identify groups of customers who frequently purchase athletic wear, formal wear, or casual wear. This allows them to send targeted promotions and product recommendations, leading to a more personalized shopping experience. Imagine teaching a robot to navigate a maze. The robot doesn't have a map or instructions. It has to learn by exploring the maze, taking actions, and observing the outcomes. It receives rewards for reaching the goal and penalties for hitting obstacles. This is the essence of reinforcement learning. The algorithm learns through trial and error, adjusting its actions based on the feedback it receives from the environment. It's like training a dog with treats, positive reinforcement for desired actions. One of the most exciting applications of reinforcement learning is in game-playing AIs. For example, AlphaGo, a computer program developed by Google DeepMind, used reinforcement learning to defeat the world champion Go player. Through millions of games against itself, AlphaGo learned to make strategic moves and anticipate its opponent's actions, eventually surpassing human capabilities in this complex game. Reinforcement learning has also been used to develop AIs that excel in video games, robotics, and even self-driving cars. Section 5. Recommendation systems, personalized suggestions. Ever wonder how Netflix seems to know which shows you'll enjoy, or how Spotify suggests songs you've never heard before but end up loving? That's the magic of recommendation systems, powered by machine learning. These systems use a type of supervised learning called collaborative filtering. They analyze your past behavior, like the movies you've watched or the songs you've listened to, and compare it to millions of other users with similar tastes. Think of it like asking a friend with similar taste in movies for recommendations. They've likely seen movies you'd enjoy, and their recommendations are based on their understanding of your shared preferences. By identifying patterns in the data, the algorithm can predict which items you're most likely to enjoy and recommend them to you. This leads to a more personalized experience, helping you discover new content you might have otherwise missed. Section 6. Image recognition teaching computers to see. Remember those capture tests that ask you to identify traffic lights or crosswalks in images? They might seem like a minor inconvenience, but they serve a greater purpose. Those tests are actually helping to train machine learning algorithms for image recognition. By identifying objects in these tests, you are contributing to the development of smarter algorithms. Image recognition is another exciting application of machine learning, allowing computers to see and interpret images just like we do. This technology is rapidly evolving and becoming more sophisticated. It uses a type of supervised learning called deep learning, which involves training artificial neural networks on massive data sets of labeled images. These networks mimic the way our brains process visual information. Just like teaching a child to recognize objects, we show the computer millions of images of cats, dogs, cars, and more, each labeled with the correct object. This extensive training helps the computer learn to identify these objects on its own. The algorithm learns to identify features and patterns in the images, such as edges, shapes, and colors. Over time, it becomes adept at recognizing these features in various contexts. With enough training data, the algorithm can recognize objects in new, unseen images with remarkable accuracy. This ability to generalize from training data to new data is what makes image recognition so powerful. This technology has numerous applications, from self-driving cars that can recognize pedestrians and traffic signs to medical imaging systems that can detect diseases in X-rays and scans. The potential uses are vast and continually expanding. Section 7. The future of machine learning. Machine learning is already transforming the world around us, and its potential is limitless. As algorithms become more sophisticated and data sets grow larger, we can expect even more innovative applications in the future. Imagine personalized medicine, where treatments are tailored to your unique genetic makeup, or smart cities that optimize traffic flow and reduce energy consumption. Machine learning can help us address some of the world's most pressing challenges, from climate change to disease prevention. However, with great power comes great responsibility. It's crucial to ensure that machine learning is developed and used ethically, addressing concerns about bias, privacy, and job displacement. By fostering open dialogue and collaboration, we can harness the power of machine learning for the benefit of humanity. Section 8. Conclusion: Embracing the future. Machine learning is no longer science fiction. It's a powerful tool that's shaping our present and future. By understanding the basics of how it works, we can become more informed citizens in an increasingly data-driven world. From personalized recommendations to life-saving medical diagnoses, machine learning has the potential to improve our lives in countless ways. As we continue to unlock its possibilities, it's essential to approach this transformative technology with curiosity, responsibility, and a commitment to using it for good. Section 9. Glossary of terms. In this section, we will explore some key concepts and terminologies that are fundamental to understanding the world of computer science and artificial intelligence. Algorithm: a set of rules or instructions that a computer follows to solve a problem. These are the building blocks of computer programs and are essential for performing tasks efficiently. Artificial intelligence, or AI: the ability of a computer or machine to mimic human intelligence. This includes learning, reasoning, problem-solving, and even understanding natural language. Data information that is collected and used to train machine learning algorithms. Data can come in various forms, such as text, images, or even audio. Deep learning: a type of machine learning that uses artificial neural networks with multiple layers to analyze data. This approach has led to significant advancements in fields like image and speech recognition. Machine learning: a type of artificial intelligence that allows computers to learn from data without being explicitly programmed. It enables systems to improve their performance over time based on experience. Neural network, a computer system modeled on the structure of the human brain used in deep learning. These networks consist of interconnected nodes or neurons that process information in layers. Supervised learning, a type of machine learning where the algorithm is trained on labeled data, meaning each piece of data is tagged with the correct answer. This helps the model learn to make accurate predictions. Unsupervised learning, a type of machine learning where the algorithm is trained on unlabeled data and must find patterns and relationships on its own. This method is useful for discovering hidden structures in data. Reinforcement learning, a type of machine learning where the algorithm learns through trial and error, adjusting its actions based on the feedback it receives from the environment. This approach is often used in robotics and game development.